The periodic table currently contains 118 elements. 94 of these are naturally found in the Earth, some only in trace amounts. The rest of the elements are man-made, manufactured in a laboratory. Only a handful of elements are just sitting around the Earth waiting to be picked up, like gold, silver, copper, iron, sulfur, and even these are usually attached to other rocks and need to be purified. Most elements are embedded in small quantities inside certain rocks called ores and need to be mined out. Some ores have more of a particular element than others. The trick is to find a rock that has the most amount of what you're after so you don't waste time crushing and heating and separating a low-grade ore that has only 5% of your metal when this high-grade ore has 15%. Solve et coagula. Separate and join together. In mining, this means getting rid of as much of the unwanted rocky material as possible to get to the element inside. It may take tons and tons of ore processing just to get a few pounds of metal. Mining ores, then refining them, is one of the most common methods to obtain individual elements on the periodic table. And now, we are going to meet each one of those individual elements. We begin with hydrogen, since hydrogen floats around in a category all by itself. Our picture is water on fire, since hydrogen is flammable and water is mostly made of hydrogen. In fact, hydrogen means water maker. Hydrogen is the most abundant element in the universe and the lightest, colorless, odorless, tasteless, and highly flammable. The Space Shuttle's main engine burns 750 gallons of liquid hydrogen every second, producing a nearly invisible 6,000-degree flame, higher than the boiling point of iron. Alkali metals, the first group on the periodic table and the most reactive. They are kept submerged in oil or kerosene to keep them from reacting to the moisture in the air. Lithium, meaning the stone, as lithium is found in many minerals. The ores we present in this segment represent just one example of the many ores where these elements are found. Lithium must be kept in mineral oil or it will start reacting with the moisture in the air. This piece is already black from only 10 minutes reacting with the surrounding air. Lithium is also the lightest of all metals and easily floats in oil. 1 cubic foot of aluminum weighs 168 pounds, but lithium only 33 pounds. Lithium alloys make strong, light metals. Lithium batteries are perfect where weight and small size are a factor. Used as a medicine, lithium can stabilize extreme mood swings, but the effective dose is very close to the toxic dose and must be carefully monitored. Sodium, from the word soda. The symbol Na is from natrum, the Latin word for soda. Soft enough to cut with a knife and highly reactive. Sodium is essential for life, carrying electrical impulses along nerve fibers. Sodium chloride, table salt, is the most common sodium compound and the principal source of sodium production. Salt is collected in seawater evaporation vats or collected in piles from salt flats, like this gigantic salt flat located in Bolivia. Compounds of sodium are used in making soap, paper, glass, and in most industries. It is the yellow-orange glow in sodium vapor streetlights. Sodium is one of the cheapest of all metals. Potassium, from potash, the ash used in ancient times for making soap and fertilizer. The symbol K is from kalium, Latin for ash. A soft, highly reactive or explosive element. You can see this sample already reacting with the moisture in the air. Similar to sodium in making glass and soap, and it has important biological functions. Potassium is used in making inks and dyes, explosives, fireworks, but mostly for fertilizers. Bananas are known for their high potassium content, but an avocado has 3 times the potassium of one banana. Rubidium, meaning deep red, because of its predominant spectral red colors here. It is related to the word ruby. Rubidium ignites spontaneously with air and reacts violently. In practice, rubidium is usually sealed in glass ampules along with a noble gas. Rubidium melts on a warm day at just over 100 degrees Fahrenheit. It is sometimes used as an element in photocells, but in general, there are relatively few commercial uses for rubidium. Cesium means sky blue because of its blue color in the spectroscope, but cesium is the only other element other than gold that is actually gold-colored. Like rubidium, cesium is usually sealed in an ampule under argon gas. It is liquid at warm room temperatures, about 83 degrees. The cesium clock, or atomic clock, is the standard measurement to measure time. 9,192,631,770 oscillations of the cesium atom takes exactly 1 second, accurate to about 1 second every 2 million years. Aside from a few medical and scientific applications, cesium has only a few commercial uses. Francium will be covered under the heavy radioactive elements. The second family are the alkaline earth metals, reactive but not as reactive as the ferocious alkali metals. Beryllium, containing beryl, since it was first found in this mineral. It is light, stiff, and is structurally stable, making it ideal for use in high-speed aircraft, cogs, gears, and structural components of the space shuttle. Expensive and toxic, but unbeatable when cost is no object. The word beryl means sweet, and early experimenters verified the presence of beryllium by its strangely sweet taste, but beryllium and its compounds are highly poisonous and should only be handled with the greatest care. Magnesium, from Magnesia, the area in Greece where this was discovered. Thin shavings ignite easily and burn brightly and are used in flares and magnesium fire starters. Lightweight and strong, magnesium alloys are found almost everywhere: bicycle frames, airplane parts, luggage, catcher masks, and rockets. Magnesium is dissolved in seawater and tons are processed out every year. Mining is another source of magnesium. So-called milk of magnesia and Epsom salts are common medical uses of magnesium. Your body has about 20 grams of this essential element. Calcium, Latin for lime. Limestone is an ancient building material and contains this element. The Great Pyramid is made entirely of limestone. When you say calcium, most people think of milk, bones, and chalk, but pure calcium is a highly reactive metal and is rarely ever seen. Pure calcium has very few applications, but compounds of calcium are used to make everything from drywall to paint and chalk and antacids. Marble used for statues is actually calcium limestone, squeezed under great pressure. Dairy products are rich in this metal, and vitamin D is often added to help the body absorb it. Calcium in water is responsible for calcification in pipes as well as stalactites and stalagmites forming in caves. Calcium is the most abundant metal in humans, averaging 2 pounds of this metal in your body. 99% of it is in your teeth and bones. If you were completely dried out, 1/3 of your remaining weight would be the metal calcium. Strontium, named after Strontian, Scotland, where the element was discovered. Another highly reactive element that is kept under argon gas or in oil to keep it from reacting with the moisture in the air. Regular strontium is not radioactive and is used in fireworks to burn bright red and to make safe glow-in-the-dark paints. But the isotope strontium-90 is highly radioactive and is the residual of nuclear explosion fallout. But if controlled, this isotope also holds potential in fueling remote weather stations and future space vehicles. Barium, Greek for heavy, as its ore was one of the most dense minerals then known. The last alkaline earth metal that isn't radioactive, but still highly reactive and kept safely in this non-reactive argon gas tube. Some barium compounds are poisonous, and others make fireworks green. There are relatively few commercial uses for barium. X-rays pass through soft tissue, but barium readily absorbs X-rays. When patients drink a barium solution, the barium absorbs the X-rays, allowing visibility of the digestive tract. Radium will be covered under the heavy radioactive elements. The halogens, meaning produces salt, as salts are often produced when combining with these elements, table salt being the most common example. Fluorine, to flow, as fluorite, the main ore, has a very low melting point. It also glows in ultraviolet light, thus producing the word fluorescent. Fluorine is a poisonous, corrosive, pale yellow gas and the most reactive element on the table, even more than the ferocious alkali metals. It cannot be stored in ordinary glass. It soon eats the glass. It is so reactive it will even try and bond with the noble gases. Though controversial, some toothpaste and city drinking water contains small amounts of fluorine to help prevent tooth cavities. Combined with carbon, fluorine becomes stable, and forms polytetrafluoroethylene, also known as Teflon. Chlorine, greenish yellow in Greek. The fourth horseman in the Apocalypse is actually named Chloros, pale green. Chlorine is a powerful disinfectant. In very small doses, chlorine is used to safely purify drinking water and swimming pools. Chlorine is extracted from molten salt by electrolysis, where the sodium and chlorine separate. Chlorine is used in a wide range of products in agriculture, pharmaceuticals, plastics. 85% of all medicines, 96% of all crops, and 98% of all drinking water are affected by the chlorine industry. Chlorine gas is highly poisonous or debilitating and has been used as a weapon, as shown in John Sargent's famous 1918 painting. Bromine, Greek for "it stinks," because of its strong, disagreeable odor, which somewhat resembles chlorine. Bromine is extracted from seawater. Bromine is a brown-red liquid and the only non-metal liquid. Typical of halogens, bromine combines with metals to produce salts, some of which are used to purify hot tubs. The largest single use of bromine is manufacturing flame-retardant chemicals used in clothing, furniture, and plastics to inhibit fire. Israel's bromine reserves are contained in the waters of the Dead Sea. Iodine. Iodine comes as shiny blue-black crystals which cannot melt. Rather, it sublimates, meaning when heated it goes immediately from a solid into a gas, a beautiful purple gas, and thus iodine means violet. It is the heaviest element your body needs and can mean the difference between good or bad health. The amount of iodine in your body would fit on the head of a pin. It is mostly located in the thyroid gland. Iodine is a powerful disinfectant and is generally found in seaweed, where, after being heated, it sublimates and the crystals are collected. Astatine will be covered under the heavy radioactive elements. The noble gases, also called inert gases, elements so satisfied with themselves they don't combine with other elements. They bear odd Greek names which reflects their exclusive nature of being noble. Helium was first discovered on the Sun using spectroscopy. Helium is Greek for sun. Colorless, odorless, tasteless, helium glows peach-colored when an electric current runs through it. Compressed helium supercools materials, lifts balloons, and provides an inert gas environment in arc welding. Helium is normally trapped with natural gas. When the temperature of natural gas is lowered, it liquefies and the helium separates away. Both products are then collected and stored. Nothing bonds with helium, not even fluorine. No compounds of helium have ever been made. Neon, from Greek neo, meaning new, the new element. Neon-filled lights glow a bright red-orange. Neon is also being tested as a refrigerant. Neon is extracted out of normal air. The air is supercooled to a liquid, and as it warms, each element changes back to a gas at a different temperature and is collected. Neon changes back at minus 410 degrees Fahrenheit. Neon is chemically inactive, and so far it has been impossible to make neon react with any other element. Argon, literally lazy or inactive. Argon is chemically inactive, but an electric current causes argon to glow a rich sky blue. One of the least expensive noble gases, argon is used as a gas shield for arc welding and cutting. It is also the inert filler gas in most light bulbs. Like neon, argon is extracted from the air through fractional distillation. Argon lasers are used in research, and smaller versions are used in precision eye surgery. Krypton. It means hidden because it is colorless, tasteless, odorless, and is one of the rarest gases in our atmosphere. An electric current causes krypton to glow a very pale lavender color, almost white. These krypton-filled light bulbs are about the only commercial use of krypton. Krypton is chemically unreactive. Fluorine can bond with krypton, but is only a laboratory curiosity. Like neon and argon, krypton is extracted by allowing liquid air to evaporate. Krypton is the birthplace of the DC comic book hero Superman. The fictional planet was named after this noble gas was discovered 40 years earlier. Xenophobia is the fear of something foreign or strange, and xenon means foreign or strange, and was the last noble gas discovered. Electrified xenon glows violet, though it is seldom used due to the high cost. Air contains very little xenon, so it is very expensive to extract. Many neon sign colors are made by combining gases or coloring the glass itself. Xenon is used for studio flash lamps, as an anesthesia, and for headlights. Amazingly, over 80 compounds have been made using this rare noble gas. I'm sure by now that it's clear that the further you go down the periodic table, the heavier the elements get. Just intuitively you know that if you take a bar of aluminum and a bar of lead, the lead is going to be heavier, if for no other reason that it's further down on the periodic table. And the same is true for gases. But how would you know? I mean, air is air, right? They're all the same. Well, here we have 5 balloons: helium, neon, argon, krypton, and xenon. You can see in the periodic table each noble gas is heavier than the one above it, just like lead is heavier than aluminum. Helium is lighter than air. It floats. Neon is also lighter than air. Argon is just heavier than air. Krypton is heavier than air also. And xenon, you've heard of a lead balloon? Well, this is it. By the way, this difference in gas density also affects the speed at which sound travels through each of these gases. That's why when you breathe helium,
your voice sounds higher, not because it changes the pitch of your voice, but because the sound is traveling faster through the helium than through normal air.
conversely, inert xenon, which is also non-toxic, is much more dense than air. So when you breathe xenon,
the sound travels much slower than through normal air. Next, we will look at the stair-step metals.